A Norse ship could cross 1,500 miles of open North Atlantic from Norway to Greenland, out of sight of land for weeks, and arrive at a specific fjord. They did it for roughly 400 years. They had no compass, no clock, no charts, and no way whatsoever to measure how far east or west they had gone. That last one should stop you. Longitude is the hard problem. Knowing your east-west position at sea defeated Europe's best minds until the 1760s, when a clockmaker finally built a timepiece accurate enough to solve it, and governments were offering fortunes for an answer. The Vikings were running regular Atlantic traffic 7 centuries before that, so they did not solve longitude. They arranged never to need it. That is the trick. And it is not mysticism or luck. It is a specific, teachable, repeatable technique, and once you see it, the whole Norse expansion looks different. You are about to see how they held a line across an empty ocean, what the sun told them and what it could not, how birds, whales, ice, and the color of water functioned as instruments, why their worst disasters happened in fog and not in storms, and why the technique that opened the Atlantic also set a hard ceiling on where they could ever go. Coastal sailing and ocean sailing are different problems, and the Norse did the coastal one for centuries before they risked the other. Along a shore, you are never lost. Headlands, mountain profiles, river mouths, and skerries form a sequence you memorize, and Norse sailing directions survive as exactly that, a spoken list of landmarks, tides, and dangers in order. A pilot knew his stretch the way you know your street. That knowledge does not transfer. Step out past the last island and every reference disappears at once. Now consider what you can actually observe from a small open ship in the middle of the ocean. You can see the sun when it is not overcast. You can see stars when it is neither cloudy nor a bright northern summer night. You can see the sea state. You can see birds. You can feel the wind and the swell. And that is very nearly the entire list. From those you can get one useful number, and only one. The sun's height at midday tells you how far north you are. That is latitude, and it is genuinely obtainable with crude tools. Watch the sun climb, mark its highest point, compare that height to what it was at home, and you know whether you have drifted north or south. You do not need arithmetic. You need a way to hold a stick, a notch, or a shadow and say higher or lower. But nothing in that list gives you east and west. Distance traveled is guesswork. You can estimate speed by watching the water go past, and you can count days, and multiply badly, and you will be wrong. Currents move you sideways without any sensation of it. Wind pushes the hull off its heading in a way you cannot fully measure. Errors accumulate every hour, and there is no way to check them against anything. The ocean gave them one number and hid the other. Everything the Norse built as a navigation method follows from accepting that honestly. They did not fight it, they designed around it. Consider how brutal that constraint is in practice. Say you are 3 weeks out of Norway, running west, and you believe Greenland is close. You are wrong by 200 miles, and you have no way to find that out. There is no instrument that will tell you. There is no calculation that will reveal it. You will discover your error when land appears, or when it does not appear and the food runs low, and those are the only 2 ways the information can ever reach you. Now add the ship. A Norse ocean vessel had no deck to shelter under across most of its length, no galley, and no way to make fresh water. Crews bailed by hand, slept in the open under skins, and ate dried and salted food and sour milk. A knar, the broad cargo type used for the Atlantic runs, carried a single square sail and could make useful progress with the wind well off the beam. But it could not work upwind the way a later rig could. If the wind sat against you, you waited. Days of waiting on an open boat with a fixed store of water is its own kind of navigation problem. Everything about the technique that follows was shaped by wanting the passage to be short. The technique is called latitude sailing, and stated plainly, it sounds almost too simple to work. You go north or south along the coast, until the sun at midday reaches the height that matches your destination's latitude. Then you turn and sail due east or due west, holding that same sun height day after day. Correct for it constantly. If the sun climbs higher, you have drifted south, so steer north. Lower, and you steer south. Keep running until you hit land. You are not navigating to a point, you are navigating to a line, and then following it. That inversion is the whole insight. A point in the ocean is nearly impossible to find. A line of latitude is 3,000 miles long and cannot be missed if you can hold it, and holding it needs only the one measurement they could actually take. The destination stops being a target and becomes wherever that line runs into a coast. Look at what that predicts about Norse geography, then check it. Norse sailing directions preserved in later Icelandic texts describe exactly this. From Hurna in Norway, sail west for Hvarf in Greenland, keeping north of Shetland so the land is just visible in clear weather, and south of the Faroes so the sea appears halfway up their slopes, and far enough south of Iceland to see its birds and whales. That is not a compass course. It is a latitude, checked against a chain of physical sightings. Read that description again and notice its precision. The sea, appearing halfway up the mountainsides of the Faroes, is a stated measurement. It fixes your distance from those islands by how much of them is below the horizon, which is a real geometric relationship between your position and their height. Whoever composed that instruction understood that the amount of an island you can see is data. Latitude sailing also explains the settlement pattern. Norse expansion runs along a band. Norway, Shetland, Faroes, Iceland, Greenland, and finally Newfoundland all sit within a fairly narrow range of northern latitudes. That is not a coincidence of climate preference. It is the shape their navigation method could reach. They could move confidently east and west along a known parallel. Moving to an unfamiliar latitude and then finding something meant giving up their only reliable instrument. Holding a latitude means measuring the sun's height repeatedly, at sea, on a moving deck, with no instrument that survives in the archaeological record. No confirmed Viking Age navigational instrument exists. None. That absence is worth sitting with, because it shapes how much anyone can claim. What exists is one object. A fragment of a wooden disc from Uunartoq in Greenland, carved with lines, found in a convent ruin. Some researchers read it as a sun compass whose gnomon shadow could be tracked against curves to find true bearing. Others read it as decoration. The debate is unresolved, and honest scholars say so. What is not in doubt is that the method does not require a fancy instrument. A notched stick held at arm's length gives you a repeatable shadow length. A knotted cord gives you a repeatable angle. The half-wheel of a shadow board floating in a bowl of water gives you a level reference and a shadow to mark. Any of these lets you record the sun's noon height at home and then match it later, which is all latitude sailing needs. Matching is easier than measuring. That distinction matters. You do not need to know your latitude in degrees. You need to know whether today's noon shadow is longer or shorter than the one you carved at your home port. A shepherd's notch on a stick answers that. Absolute measurement is a much harder problem than comparison, and the Norse only ever needed comparison, which is why no instrument had to survive. There may never have been one worth keeping. Timing was harder than height, though. Noon is the sun's highest point, and finding it means watching the climb slow, flatten, and reverse, which takes patience and a steady reference on a deck that will not hold still. Get it wrong and your reading is low, so you watch for a long stretch either side and take the maximum. Then there is the northern summer, which breaks the method in a way people rarely mention. Above the Arctic Circle in high summer, the sun does not set, and at Iceland's latitude, the nights barely darken. Stars vanish as a reference for months. That removes the entire nighttime check and leaves the noon sun carrying everything. Meanwhile, in deep winter, the sun barely clears the horizon, and the readings compress toward useless. The sailing season was not a matter of comfort. It was the window in which the instrument worked. The ocean gave them one number and hid the other. And for a few months, a year, it hid that one too. Then there is the Sunstone, and here the story gets genuinely strange. Norse sagas mention a Solarstein used to find the sun in overcast weather. For a long time that read as legend. Then it was pointed out that certain crystals, notably Iceland spar, a form of calcite that occurs abundantly in Iceland, split light by polarization. Rotate such a crystal against a cloudy sky, and the brightness of the two images changes, and the point where they match reveals the direction of polarized light, which points back toward the hidden sun. Laboratory work has shown the technique functions, with usable accuracy, even in thick overcast and after sunset. Direct proof from a Viking ship is still missing. A piece of Iceland spar was recovered from an Elizabethan wreck off Alderney, centuries later, which shows the material was carried aboard ships at some point. For the Norse themselves, the case rests on saga references plus demonstrated physics. Treat it as plausible and unproven, which is the accurate position. Beyond the sun, the Norse read the ocean itself, and the sophistication here is easy to underrate. Birds were the most useful. Seabird species have known ranges and known behavior, and a navigator who could identify them was reading a distance to land gauge. Puffins and guillemots stay relatively close to breeding cliffs. Fulmars range far, and the direction of flight matters. Birds heading out in the morning and back at evening give you a bearing toward a colony you cannot see. Norse crews also carried ravens deliberately. The settlement story of Iceland has Floki releasing ravens from his ship. The first returns, meaning no land is closer than the ship. The second circles and comes back. The third flies off and does not return, and he follows it to land. Whether or not that specific voyage happened as told, the method is sound, and it is a genuine instrument. A bird released at sea will head for the nearest land if it can detect one, and its behavior is the readout. Whales gave position information too. Different whale species concentrate in different waters, over particular banks and along particular fronts, and Norse sources name whale sightings as waypoints. Feeding grounds sit above fixed underwater features, so a whale concentration is effectively a marker anchored to the seabed. Water itself was legible. Coastal water differs from deep ocean water in color, in what floats in it, and in temperature. Driftwood, fresh vegetation, cloudiness from river silt, all of it says land upwind or upcurrent. And ice matters enormously in the north. The edge of pack ice, its texture, and a distinctive brightening on the horizon where light reflects off ice below the sightline. All of these could be read. Swell was perhaps the subtlest reading of all. Ocean swell travels in stable directions over long distances, and an experienced sailor can feel more than one swell system in the motion of a hull. Holding a fixed angle to the dominant swell gives you a heading reference that works in fog, at night, and under total overcast, when the sun is useless. Pacific navigators developed this to a very high art, and there is every reason to think Norse sailors used it too, since the information is available to anyone who spends a life on a small ship. Notice the redundancy across all of that. Sun for latitude, swell and wind for holding a heading, birds and whales for distance to land, water and ice for the final approach. No single one is sufficient, and none requires literacy or arithmetic. It is a layered system, and its failure mode is specific. The Norse Atlantic route was not safe, and the sagas are unusually blunt about that. Numbers from the settlement of Greenland make the point. Eric the Red left Iceland with a fleet described as 25 ships. 14 arrived. The rest were lost or turned back. That is a casualty rate that would close any modern route permanently, and they kept sailing it for 4 centuries. Look at what specifically killed them, though. Fog and prolonged overcast were worse than storms. A gale is dangerous and short. Days of thick weather remove the sun, which removes latitude, which removes the entire method, and leaves a ship holding a guessed heading while currents move it silently. The sagas have a word for that condition, Hafvilla, meaning bewilderment at sea, a state of being lost with no reference. It appears repeatedly, and it is treated as a distinct category of misfortune rather than as bad luck. Hafvilla is what a navigation system based on the sun looks like when the sun is gone. Ice added a second failure mode, and it moved. Greenland's approach is guarded by drifting pack ice, whose edge shifts by season and by year. A correct latitude does not help if the coast behind it is sealed. Sagas describe ships held off, driven along an ice edge, and forced to overwinter or turn back. And the settlers' own sailing directions warn about closing the Greenland coast too far north for exactly that reason. Currents were invisible and relentless. A current called the East Greenland runs hard south along that coast, and a ship arriving on the right parallel could still be carried well past its fjord without anyone aboard sensing motion. There is no way to feel a current from a boat inside it. You feel wind and you feel swell. A body of water moving as a whole gives you nothing at all, which is precisely why the east-west error keeps growing, no matter how carefully you hold your latitude. And here is the part that turns the whole story around. North America was found by exactly that failure. Bjarni Herjolfsson, sailing for Greenland, was carried off course in fog and lost his bearings. When the weather cleared, he found himself off a wooded, non-mountainous coast that was clearly not Greenland. He did not land. He followed the coast, worked his way back to the correct latitude, and reached his destination. And then he reported what he had seen. That report is what Leif Erikson later acted on, and Vinland followed from it. So the first European sighting of America was a navigation error, correctly recognized as one, by a man disciplined enough not to explore and precise enough to describe where he had been. The system's weakness produced the discovery, and the system's strength let him recover from it and get the information home. Archaeology confirms the arrival. At Lonsor Meadows in Newfoundland, a Norse site with turf buildings, an iron smithy, and characteristic artifacts, is dated to around 1000 CE. Recent research using a solar storm signature in tree rings has pinned Norse activity there to the year 1021 with unusual confidence. Latitude sailing opened the North Atlantic and simultaneously drew a boundary the Norse never crossed. Think about what the method requires. A destination whose latitude you already know. A home latitude you can compare against. A coast at the far end long enough that a line of latitude will strike it. And a sun high enough in the sky to give a usable reading. Remove any of those and the technique stops working, which means the method cannot discover anything. It can only return you to a place someone already found, or extend along a parallel you already occupy. Every step of Norse expansion was a short hop to something within reach of a known latitude, usually already sighted by someone blown off course. Shetland to Faroes to Iceland to Greenland to Newfoundland is a chain of adjacent, similar latitude coasts. Sailing south into unknown water, deliberately, was not something the method could support. Compare that with what happened 5 centuries later. Portuguese and Spanish ocean navigation had the magnetic compass, which gives a heading independent of the weather. It had celestial instruments with graduated scales, giving latitude as a number rather than a comparison. It had written charts and sailing logs, so knowledge accumulated across voyages instead of living in one pilot's memory. And it had a formal solution for dead reckoning, so distance run could be recorded and corrected. None of that is better seamanship. The Norse were superb seamen. It is a different information system, and it permits a different act. With a compass and a written record, you can sail southwest into blank ocean for weeks, know roughly what you did, and repeat it or correct it next time. Latitude sailing cannot do that, because it has no memory outside a man's head and no reference outside the sun. The Greenland colonies died out in the 15th century. As the climate cooled, the ice edge moved, and the trade in walrus ivory that funded them collapsed. The route closed with them. And when Europeans came back to those waters, they came with compasses and charts, and they did not know that anyone had been there before. Strip away the horned helmets, and one question remains. How good were they, really? Very good, at a specific thing. Norse navigation was a precise, conservative, empirical system, and its precision lived in exactly the places you would expect from people with no instruments and no writing. In the accumulated observation of what a bird means, what a swell means, how much of an island should be visible from a correct course, and how high the sun stands at home. That knowledge was carried in memory and in speech, and it was carried by individuals. Which tells you the real fragility of the whole enterprise. A ship's knowledge could die with a pilot. There was no way to write down a course in a form that a stranger could follow. So the route from Norway to Greenland existed only as long as men who had sailed it kept sailing it and kept teaching it. When the Greenland trade stopped, the route did not go into an archive. It stopped existing. Compare that with what a chart does. A chart survives its author. And that, rather than any question of courage or skill, is the honest difference between Norse expansion and the voyages that came later. The Norse could reach a line and follow it. What they could not do was leave behind a description that would let someone who had never been there do it again. Worth being careful about one thing, though. It is tempting to file this under a tidy story about progress, where writing beats memory and instruments beat skill. That reading is too clean. The sailing directions preserved in Icelandic texts show the Norse were moving toward written description, in their own idiom, listing landmarks and sea states in order. Something was being recorded. It just was not a chart, and it could not be used by a stranger. Look at what their system optimized for instead. A method needing no instrument cannot lose its instrument. A method needing no arithmetic works with an illiterate crew. A method built on comparison rather than measurement cannot be thrown off by a miscalibrated scale.
Hold the course,
In a
west
world
by
with
north,
no
past the
workshops
white ice.
making precision
The current
brass,
runs strong
no
here.
printing,
West by
and
north,
no
I
way
see the
to
blink.
replace a broken tool mid-ocean, a technique that lives entirely in a man's trained attention is not a limitation. It is the robust choice. They paid for that robustness in reach, and they knew the price. Which is why the sagas treat Hafvilla as a named condition rather than as failure. Being lost was an expected state of the system, not an aberration in it. You planned for it, you survived it, and when the sky cleared, you found your line again. A navigator who had never been bewildered at sea simply had not sailed far enough. 1,500 miles of open North Atlantic, held on nothing but the height of the midday sun, checked against birds and whales and the color of the water. They arranged never to need the measurement they could not take, and it worked for 400 years, right up until the last man who knew the way stopped making the crossing.